things to do. Okay? Let's talk imaginary numbers. Okay? Now, if you all recall from Algebra 1, I equals the square root of -1. Because we can't take the square root of -1. Why is that? Well, let's say I have, let's use 2 for an example. Let's say I go positive 2 squared. Well, 2 times 2 is positive 2. Or, oh boy. Sorry. 2 times 2 is positive 4. Okay, let's say I go -2 squared. I get positive 4. So the square root of 4 is either plus or minus 2. Recall that? But there's no way I can take the square root of a negative number in here, because I can't take a number times itself and get a negative number as a result. Okay, both these numbers are positive. So that's why I is the square root of -1. Now, while we're here, let's review this. If I is the square root of -1, that means I squared is the square root of -1 squared, which is -1. Remember these rules? I cubed is I squared times I, right? Well, I squared we know is -1 times I, so this is -I. I to the 4th is I squared times I squared, which is -1 times -1, which is +1. I to the 5th is I to the 4th times I. Well, we know, we just found I to the 4th is +1 times I get I. Okay, and this pattern will continue to repeat itself. Okay, this pattern will continue to repeat itself. So, I to the 1st is obviously I. I squared is -1. I to the 3rd is -I. And I to the 4th is +1. And then we start over. I to the 5th is I. Positive I. I to the 6th is -1. I to the 7th is -I. And I to the 8th is +1. Okay? Remember our tricks here. If the power was even, we either had 1 or -1. If it was divisible by 4, it was positive, right? Divisible by 4. What did we do to figure out our i's? Well, we took whatever the number was, we took the exponent if it was odd. If the exponent was odd, and we subtracted 1, right? So if it was I to the 23rd, we would subtract 1, okay, just for purposes. So that'd be I to the 22nd. Well, I to the 22nd would be -1 because 22 is not divisible by 4. So that means that I to the 23rd is -I, okay, because the next number follows, let's use a different color here, the next number follows the same positive-negative pattern. So if I'm doing I to the 23rd, I subtract 1 to see if my I know it's odd, so I know it's going to have an I in it, and I look at the even exponent 1 below to decide whether it's positive or negative. In this case, I to the 23rd is -I. Okay? Should be review from last year. If we need to discuss it more in class, we will. Okay? Real numbers. Real numbers are basically anything that you can plot on a number line. So real numbers include the counting numbers. So if this is 0, 1, 2, 3, they include integers, so we can add negatives. All those. -2, we can add fractions. -1.5. 1/2. We can also add irrational numbers. Okay, we can also add irrational numbers like square root of 3. Okay, anything I can graph is a real number. Okay? Now, i's I can't graph on here. Imaginary numbers I can't graph on here because they're not real numbers. Okay? Counting numbers, integers, rational numbers, irrational numbers, they're all real. Okay? Remember that was the story of Ugg and Lee. And how they discovered all the numbers. Counting numbers, whole numbers. Okay? All those are part of the real number system. So a complex number is a number that combines a real part and an imaginary part. So in general, it's A plus BI, okay? And A and B are real numbers. Okay, well, we've seen this before. Example 3 plus 2i. That is a complex number because we have a real part and we have an imaginary part. Okay? A real part and an imaginary part. Complex numbers. Okay? Now, simplifying complex numbers. Okay? Simplifying complex numbers. I want to go through examples the book has. We're going to go through the 5 examples here. Okay, so I'm on page 21 if you want to go with me. The first example is the square root of negative 25. Okay, now remember, this is how we break this down. I can break this down into the square root of negative 1 times the square root of 25, because 25 times negative 1 would be negative 25. Okay, well, I know that the square root of negative 1 is I, and I know the square root of 25 is 5, so my answer is 5i. Okay? The next one they have there is the square root of negative 7. This is B, example 1, part B. Well, I can break that down into the square root of negative 1 times the square root of 7. Square root of negative 1 is I, times the square root of 7. I can't break that down anymore. So that's my answer. I'm done. Okay? Example 2. Example 2. Okay, it's just right below it there, but now we're going to add some things to it. So I've got the square root of negative 9 minus 2 times the square root of negative 25. Well, let's break this down. Okay? We've got the square root of negative 1 times the square root of 9. That's good. Minus 2 times the square root of negative 1 times the square root of 25. Breaking everything down so I can see all my i's and all my radical numbers here. Okay? Well, this is I, and this is 3. Okay? Square root of negative 1 is I, square root of 9 is 3. Minus 2 times I, again, times square root of 25 is 5. Okay? Well, now we're just algebraizing here. So we've got 3i minus 2 times 5 is 10i. Well, since they both have I in it, I can now subtract. So I end up with negative 7i. And there is my answer. Okay? Some examples, some examples. Good stuff. Good stuff. All right, on page 22, we'll take a look at example 3. I'm going to build a new page here. Example 3. We've got 2 plus 3i plus 4 plus 5i, okay? Well, it's plus. It's not multiplication, so we don't have to FOIL or anything, don't have to multiply anything through. We can just add up our like terms, okay? They've got the parentheses in there to trick you. Don't worry about it. We can rewrite it as 2 plus 3i plus 4 plus 5i. Okay, well, 2 plus 4 is 6. 3 plus 5 is 8i. There's example 3, easy enough. Now example 4 gets a little trickier. Example 4 gets a little trickier. Here we go. 2 plus 3i times 4 plus 5i. This time they are being multiplied by each other, so this time I do have to FOIL. I do have to multiply everything. Okay? Again, FOIL. Multiply first, outside, inside, last. Essentially, you're doing the distributive property twice. I've got to multiply the 2 by everything over here, and I've got to multiply the 3i by everything over here. Okay? Well, 2 times 4 is 8, plus 2 times 5i is 10i, plus 3i times 4 is 12i, and 3i times 5i is 15i squared. Okay? So bring us to a good point. Okay, so now I've got 8 plus 10 plus 12 is 22i. Now, plus 15i squared. Never leave, excuse me, never leave I with an exponent. Because back here, we showed we could simplify all those. What does I squared equal? It equals -1. That's why we need to memorize that list. At least learn how it works. Is this the right one? Oh, yeah. So I've got 15i squared, which is, I almost wrote it again, -1. Okay, so now I've got 8 plus 22i minus 15. 8 minus 15 is -7 plus 22i. In complex numbers, you should always just have two pieces, a real and an imaginary part, because if you have I with any sort of exponent, it's going to simplify. If you have I with any sort of exponent, it is going to simplify. Okay? Here we go. Last one. Oops. We're going to do example 5. Last one. Divide 2, oh no, not 2, that's 2i. Sorry, I saw it wrong. 5 minus 2i divided by 4 plus 3i. Okay? Here we go. Now, here's a little trick. Here's a little trick. If I multiply by the conjugate, I'm going to get rid of all my middle terms. Let's say I had 2 plus, or let's do this. Let's make it easier. Let's say I had x plus 2. Now if I multiply by the conjugate, which is the same thing, it's just you change the sign. So the conjugate of x plus 2 is x minus 2. Okay, if I FOIL this out, I end up with x squared minus 2x plus 2x minus 4. Well, what happens when you multiply conjugates together is the two middle terms disappear. Okay, so if I look at this with imaginary numbers, since I have if I'm going to end up with I squared, I can simplify that. So what I want to do over here is multiply top and bottom, numerator, denominator, by the conjugate of the denominator. So I'm going to multiply by 4 minus 3i. Because that'll get rid of all my i's in the denominator, and that'll be a good thing. That will be a good thing, because I don't want any imaginary numbers in the denominator. Okay. Multiply by 4 minus 3i. Now I can do this again. Review, because anything over itself is 1. So 4 minus 3i over 4 minus 3i is just 1. Okay, well, let's FOIL the top. 5 times 4 is 20. 5 times -3i is -15i. 4 times -2i is -8i. And then I've got a positive 6i squared. All divided by 16 minus 12i plus 12i minus 9i squared. Okay, well, I've got some simplifying to do. That's going to become 0. Okay, this is going to become -1, and that's going to become -1. So I've got 20, and let's add up my i's up there on the top. in the numerator. So that's negative